Now we'll move on to look at the muscles that produce movement at the joints of the ankle region. In doing this, we'll meet most, but not all, of the muscles that are in the leg. There are 4 muscles that are in the leg, which we'll leave out of the picture till the next section. These are the long flexors and the long extensors of the toes. Along with the muscles, we'll meet the various layers of deep fascia, which divide the muscles of the leg into rather distinct compartments. We'll start with the muscles that produce dorsiflexion and plantar flexion at the ankle joint. Next, we'll look at the fascial layers and compartments. Lastly, we'll look at the muscles of inversion and eversion. First, then, the dorsiflexors and plantar flexors. Dorsiflexion involves just lifting the foot. Plantar flexion involves lifting the whole body. So it's not surprising that the muscles for plantar flexion are much larger than the ones for dorsiflexion. There's one muscle on the front of the leg for dorsiflexion, tibialis anterior. There are 3 on the back of the leg for plantar flexion, gastrocnemius, soleus, and plantaris. Here's tibialis anterior. Tibialis anterior arises from the lateral surface of the upper tibia and from the interosseous membrane. The tendon of tibialis anterior passes under the extensor retinaculum and winds around the medial side of the tarsus to insert right down here on the first cuneiform bone and on the base of the first metatarsal. The main action of tibialis anterior is to produce dorsiflexion at the ankle. Dorsiflexion is not the only action of tibialis anterior. It also has a role in producing inversion, as we'll see shortly. What's more, tibialis anterior is not the only muscle that produces dorsiflexion. It's assisted in that by the long extensor muscles for the toes, which we'll see in the next section. We'll move on now to look at the muscles that produce plantar flexion. 2 large muscles, gastrocnemius and soleus, and 1 small muscle, plantaris, join together to form the massive calcaneal tendon. Here's gastrocnemius. Here, deep to it, is soleus. Gastrocnemius has 2 heads, a medial and a lateral. These arise, as we've seen, from the medial and lateral condyles of the femur. The 2 heads of gastrocnemius unite, forming a flat tendon. The gastrocnemius tendon, in turn, unites with the tendon of soleus to form the calcaneal tendon. To look at soleus, we'll remove gastrocnemius. Here's the whole of soleus. Here's its medial border. Here's its lateral border. Here's the cut edge of the gastrocnemius tendon. Soleus arises from the medial edge of the tibia, from this oblique line on the back of the tibia, and from this area on the back of the fibula. Between the fibula and the tibial origins of soleus, there's an arch of fibrous tissue. The popliteal vessels and the tibial nerve pass beneath this arch. Here are their divided ends. For completeness, we'll add plantaris to the picture. Here it is. Plantaris arises here, on the lateral epicondyle of the femur. The long tendon of plantaris runs almost to the ankle before uniting with the calcaneal tendon. The calcaneal tendon is also known as the Achilles tendon, or simply the heel cord. It inserts into a broad area here, on the back of the calcaneus. In front of the calcaneal tendon, there's a pad of fat, which fills the gap between the tendon and the back of the ankle joint. The action of soleus, gastrocnemius, and plantaris is to produce plantar flexion at the ankle joint. Their action lifts us up off the ground when we stand on tiptoe. When balanced against gravity, the same action controls our rate of descent. In addition, these muscles provide an important part of the propulsive force in normal walking, in going uphill, in running, and in jumping.